Okay, for today's lesson, we're still going to focus on inequalities, but today we're going to talk about absolute value inequalities. So this will be 1-6, day 2 lesson. Okay, with absolute value inequalities, just like with absolute value equations, you're going to have two parts. Okay, just like we had two equations when we solved absolute values, we're going to have two parts. Now you're going to have to figure out which one's an and which one's an or. So when we do a number line, you're going to know whether or not they connect or whether or not they go away. So if it's a greater than, it's an or problem, which means when you're graphing on the number line, wherever your points are, they're going to go away from each other. This also works for greater than or equal to. Then less than or less than or equal to, those are and problems, which means wherever your points are, then you're going to connect the lines. Okay? So we're going to solve and graph on number lines just like we've been doing with inequalities. Okay, at any time that you feel that I'm going too fast, you're welcome to pause the video, okay? So if you don't get something right now or you're not sure what I said, always pause the video, go back and watch it, okay? Whenever you're doing the ands or the ors, okay, you have to make sure the absolute value is by itself first. So by looking at this first one, absolute value of c is greater than or equal to 8. Absolute value is by itself. Okay, it's a greater than, so this is going to be an or problem. So how you set your two inequalities, you take what's inside the absolute value, you drop off the absolute value sign, okay? So the first one kind of stays the same. Then you're going to do or. When you're doing equations, you make the right-hand side negative. When you're doing inequalities, not only do you make the right-hand side negative, but you also flip the sign. Okay, here's the reason why. Because when you're making it negative, it's like you divide it by a negative. When you divide by a negative, you always have to flip the sign. Okay, then I would look at my inequalities. Do I need to solve them for the variables? These are already solved, so this is your answer. Okay, then I need to graph it on the number line. Just like we talked about yesterday, if you want to make breaks in the number line, you can. Just remember, your number line has to go from least to greatest. Same rules before about open or closed circles. So these are both going to be closed. Okay, and it says greater than or equal to 8 or less than or equal to negative 8. So those arrows go away from each other. We'll do another basic one. So absolute value is already by itself. This is a less than, which means this is going to be an and problem. Okay, now we can write this as one inequality altogether like you saw yesterday for ands, but I think it's easier if you just do it separately, but remember that they're going to connect together. So first one stays the same. You just drop off the absolute value. And write the word and in between. Then the second one, you flip the sign and you make it negative. Alright, then if you needed to solve for the variable, you'd solve for the variable. These are already solved. So this is your answer. So then I'm going to do my number line. And I'm going to put a break in on this one. You both have open circles. less than 6 and greater than negative 6, so and means they connect. Okay, third example. So this is a greater than, so this is an or. Okay, the absolute value is by itself, so we're going to go ahead and split it up. So I have 3x plus 5 is greater than 14, or 3x plus 5 is less than negative 14. So nothing changes on the inside, those stay the same, it's the outside part on the second part. You flip the sign and make it negative. Okay, now both of these we have to solve for x because they're not solved yet. So I would subtract 5. So I have 3x is greater than 9 divided by 3. So x is greater than 3. Or, okay, now I go solve the other one. I would subtract 5. So I have 3x less than negative 19 divided by 3. Okay, this one doesn't come out perfectly, and make sure you don't put it as a decimal because it's not a perfect decimal either. So you can leave it as negative 19 thirds, or I'm going to change it to negative 6 1/3. Okay, don't put negative 6.3 because that's not what a third is. Okay, when I graph this on a number line, it's an or, so these are going to go away from each other. If you want to graph fractions, you can. If you want to just put them in between like I'm going to, that's fine. So open circle at 3, open circle at negative 6 1/3, and then they're going to go away from each other because it's an or. Okay, before you can decide if it's an and or an or, you have to get the absolute value by itself. So for the first 3, we were good. Those are already by itself, but this one's not. So we have to get it by itself first before we can decide if it's an and or an or, and before we can split it apart. So the first thing we would do is we need to get rid of this negative 6. Excuse me. So we'd add 6 to both sides. So then I have 3, absolute value of 2x minus 4 is greater than 18. Okay, then I saw that 3 in front, so it's multiplied, so the opposite of multiplying would be dividing. So then I have the absolute value of 2x minus 4 is greater than 6. Okay, so this is a greater than, so we know this is going to be an or. So then I can split it apart. So I would have 2x minus 4 greater than 6, or 2x minus 4 less than negative 6. So I flip the sign and make it negative. Okay, and then I would solve for x. So first one would add 4. So I have 2x greater than 10. Divide by 2, so I have x greater than 5. Okay, the other one I would add 4. So I have 2x less than negative 2. Divided by 2, x is less than negative 1. Those are both solved for x, so that's your answer. Okay, I'm not going to do a break in the graph on this one because those aren't very far apart. If you want to, that's fine. Just always remember your number line has to go from least to greatest. These are having open circles, and ors mean they go away from each other. Greater than 5 or less than -1. Okay, so those are your examples for the absolute value. I have a couple more I'm going to put in on the notes, so if you want to go look at the notes on Canvas, there'll be a couple more examples that you can use. The homework that's on the notes is actually going to be your homework. I'll go ahead and write it down right here. Okay, same page that you did for yesterday. You're going to do 16 through 21 and 35 through 40. Okay, and just like yesterday, you're only going to graph the evens. Okay, and I'll put that in a separate page on Canvas so you can see it even better. Okay, but page 45, 16 through 21, and 35 through 40, and you're only going to graph the evens.